press the bell icon on the YouTube app and never miss another update.
Hello students. We continue the next problem in permutation and combination concept up to fourth third problem we finish up. Fourth problem in the exercise 7.3. Fourth problem, find the number of four digit numbers that can be formed using the digits 1, 2, 3, 4 and 5. If no digit is repeated. One more question is there. How many of these will be even? How many of these will be even? Okay, so same question what we discussed in the last class, same type of question. Total digits are 1, 2, 3, 4 and 5. N is equal to 5. Even digits are 2 and 4. N is equal to 2. Then we have to arrange 4-digit number. First one, we have to form 4-digit number. Correct? We have to form 4-digit number. Then that can be found 4-digit. If no digit is repeated, 4-digit number without repetitions. Okay, without repetition. Right here, without repetition. The total number of arrangements is equal to, N is equal to what? 5. R is equal to what? 4. 5 is 5p4. 5 factorial divided by 5 minus 4 factorial. 5 factorial divided by 1 factorial, 5 factorial. So calculate 5 factorial. 5 factorial is 5 into 4, 3, 2, 1. 20, 60, 120. correct? 5 factorial, 5 into 4 into 3 into 1. First question is over. How many of these will be even? Yes. Second question. Second, I write here only. How many of these will be even? Correct? So n is equal to 4. We have to arrange 4 at a time. 4 at a time. So for even, this box is very important. Correct? The unit place. This is what? The unit place, 10th place, 100th place, 1000th place. Okay. So here, how many digits are there? Even digits? 2 digits. This box can be filled in how many ways? 2p1 ways. Correct? This box can be filled in 2p1 ways. Then remaining 1, 2, 3. 3 boxes are there. 3 boxes are there. This can be done. So n is equal to 5. 2 is over. 4 p3 ways. 1, 2, 3. 4. 3 boxes, because one number is already inserted here, remaining because without repetition. 1, 2, 3. 3 boxes. N is equal to 4. 4 p3 ways. Okay. For P3 ways. Second one, the total, directly we write total number of 4-digit even numbers is equal to 2p1 into 4p3. 2p1 is what? 2. 4p1. 4 factorial divided by 4 minus 3 factorial. 2 into 4 factorial divided by 1 factorial. 2 into 4 into 3 into 2 into 1, because 4 factorial. So 6, 24, 48. See, 3 2s are 6, 6 4s are 24, correct? 24 into 2, 48 ways. This is 120 and this is 48. This is the answer. See, this is the answer. Next problem. I think fifth problem in the exercise 7.3. Very simple problem. From a committee of 8 persons, from a committee of 8 persons, in how many ways can we choose a chairman and a vice chairman, assuming one person cannot hold more than one position. more than one position. One person cannot hold more than one position. Okay, so from a committee of 8 persons, in how many ways we can choose a chairman and vice chairman? A chairman and vice chairman. One person cannot hold more than one position. Means if it is a person is a chairman, he is not a vice chairman. So if it is a person is a vice chairman, he cannot a chairman. So this can be done. See, observe, very simple fundamental principle of counting, very easy method. This is for chairman, this is for vice chairman. So total number of digits is 8. This can be done in how many ways? 8 ways. Correct? This can be done in 8 ways. Since repetition of the digit is not allowed, this can be done in 7 ways. So total number of ways. Total number of ways 8 into 7. 8 into 7. Correct? So how can we solve? Very simple. 2 boxes are there. The total persons are 8. Taken 2 at a time. Correct? One is chairman, another one is vice chairman. That is R is equal to 2. Required number means the total number of arrangements. The total number of arrangements is nothing but 8p2. Total number of arrangement is nothing but 8p2. So that is nothing but 8 into 7. That is nothing but 8 into 7. So 8 into 7. So this is the answer. Sorry, 8 into 7, 56. The total number of arrangement is how much? It is 56. This is the answer. See this question. Next question. Sixth question. Find n if n minus 1 p3 is to n p4 is equal to 1 is to 9. Very interesting question. Find the value of n. Find the value of n. n minus 1 p3 is to n p4 is equal to 1 is to 9. Okay. Given what? n minus 1 p3 is to n p4 is equal to 1 is to 9. So that implies n minus 1 p3 divided by n p4 1 by 9. A is to B we can write as A by B. Okay. So cross multiply it 9 into, or else we solve here only, then we cross multiply n minus 1 p3 n minus 1 factorial divided by n minus 1 minus 3 factorial whole divided by n factorial divided by n minus 4 factorial is equal to 1 divided by 9. NPR formula. I use NPR formula, n factorial divided by n minus r factorial. That I can return here. N minus 1 factor. That implies n minus 1 factorial divided by n minus 1 factorial minus 1 minus 3 minus 4 n minus 4 factorial. N factorial I can return as n into n minus 1 factorial. N minus 4 factorial is equal to 1 divided by 9. 1 divided by 9. N minus 4 factorial, n minus 4 factorial get cancelled. N minus 1 factorial, n minus 1 factorial get cancelled. 1 divided by n is equal to 1 by 9. Very simple method I can calculate. Reciprocal. N is equal to 9. Very interesting problem. Very simple problem. N is equal to what? N is equal to 9. Understand? Next problem. See this problem first carefully. Seventh problem in exercise 7.3. Find R if two problems are there here. First one, 5PR 2 into 6PR minus 1. 5PR 2 into what? 6PR minus 1. Okay. Given 5PR 2 into 6PR minus 1. Use the formula 5 factorial 5 minus R factorial. That is equal to 2 into 6 factorial 6 minus R minus 1 factorial. This is the first step. I applied the formula. 5 factorial divided by 5 minus R factorial. 6 factorial like 6 into 5 factorial. Minus R, minus into minus plus 1 plus 6, 7 R factorial. 7 minus R factorial. Why I write 5 factorial? 5 factorial get cancelled. 1 divided by 5 minus R factorial. 1 divided by what? 5 minus R factorial. That is equal to 6 into 2, 12. 12 divided by 7 minus R factorial. 7 minus what? R factorial. Okay. So this we can return as 1 divided by 5 minus R factorial as it is. 12 divided by 7 minus R I can run as 7 minus R 6 minus R into 5 minus R factorial. 7 minus R 6 minus R into 5 minus R factorial. 5 minus r factorial, 5 minus r factorial what? Get cancel. On cross multiplying, 7 minus r, 6 minus r is equal to 12. 7 minus r, 6 minus r is equal to 12. So, if I substitute 1, 6 into 5, it is not 12. By inspection method only we calculate. If I substitute 2, suppose by inspection method, if r is equal to 1, 7 minus 1, 6 minus 1, 6 into 5, not equal to 12. Correct? Not equal to 12. If r is equal to 2, because we want 12, 7 minus 2, 6 minus 2, 4 into 5 into 4, it is 20, not equal to 12. If r is equal to 3, 7 minus 3, 6 minus 3, 4 into 3, it is equal to 12. Therefore, r is equal to 3. Or else you factorize quadratic equation, we got one value is negative and one value is positive. Negative we cannot take, r is equals, r must be greater than or equal to 0, less than or equal to n, r is equal to 3. Understand this problem? Observe this problem simplification. Next problem. Next one, same question, second question. 5pr is equal to 6pr minus 1. 5pr is equal to 6pr minus 1. Given 5 factorial divided by 5 minus r factorial. 5 factorial divided by 5 minus r factorial. 6 factorial divided by 6 minus of r minus 1 factorial. 6 minus of r minus 1 factorial. 5 factorial divided by 5 minus r factorial. 6 factorial like 6 into 5 factorial divided by minus r, minus into minus plus 7 minus r factorial. Correct? Minus 7 minus 5 factorial get cancelled. 1 divided by 5 minus r factorial. 1 divided by 5 minus r factorial. 1 divided by 5 minus r factorial. 6 divided by 7 minus r factorial we can return as 7 minus r, correct? 6 minus r into 5 minus r factorial. 5 minus r factorial, 5 minus r factorial get cancelled. So on cross multiplying, 7 minus r, 6 minus r is equal to 6. So the last problem I solved by inspection method. This problem I can solve by quadratic equation method. Or else inspection method is very easy. Okay. So we want 6. 7 6 42 minus 7r, correct? Minus 6r, minus into minus plus r square minus 6. I shift here from right side to left side. Plus 6 becomes minus 6. R square minus 13r plus this one is how much? 36. 36 is equal to 0. Correct? R square minus 13R plus 36 is equal to 0. So R square minus 9R minus 4R plus 36 is equal to 0. 36 is equal to 0 for factorization. In these two terms, R take common, R minus 9. In these two terms, minus 4 take common, R minus 9 is equal to 0. R minus 4 is equal to 0 or R minus 9 is equal to 0. R is equal to 4, R is equal to 9. Okay. N is 5 and 6. So this value is not. Because since R is greater than or equal to 0, less than or equal to N, that implies R is equal to 4. That's why I solve by quadratic equation, because R must be greater than or equal to 0, less than or equal to N. That's why R is not equal to 9, R is equal to 4. Observe this problem. These type of problems are very important to find N and to find R. Next problem. So 7 over exercise 7.3, 8th problem. How many words with or without meaning? Means if they are given meaning, okay. If they are not given meaning, okay. Can be formed using all the letters, of the word equation, using each letter exactly once. This is very important, using each letter exactly once. This type of problem we solved in fundamental principle of counting also, correct? So here we use permutation. How many words with or without meaning can be formed using all the letters of the word equation? Okay, solution. The word equation contains how many digits? 2, 2, 6, 2, 4, 6, 8 digits. The word equation contains how many digits? 8 digits. Then the total number of arrangements taken all at a time. The total number of arrangements taken all at a time is given by 8p8. Correct? The total number of arrangements taken all at a time is given by what? 8p8. So we discussed in the last class, npn is nothing but what? N factorial. 8 factorial. That is nothing but what? 8 factorial. I write once again, since npn is equal to n factorial. npn is equal to what? N factorial. Okay. Now 8 factorial. So we solve this one. 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. 8, 7, 6, 5, 4, 3, 2, 1. Calculate and find out the answer. You also calculate. $40,320. The total number of arrangements of the word equation is 40,320. Observe this problem. Next problem. Ninth question. How many words with or without meaning, with or without a meaning, can be formed right here only, can be made from the letters of the word Monday, of the letters Monday. One more condition he has given, assuming that no letter is repeated. If so, he has given 3 questions. First one, he has given 3 questions. 4 letters are used at a time. 4 letters are used at a time. Second one, all letters are used at a time. All letters are used at a time. Third question, all letters are used but first letter is a vowel. First letter is a vowel. See this question first. How many words? Same type of question what we discussed in the previous problem. Same question, but three questions are there. Three questions are there. How many words with or without meaning can be made from the letters of the word Monday? Solution. I write here. With or without meaning. The word Monday. The word Monday contains 6 digits. So then here, assuming that all letters are used, one more is there, vowel. Vowels are, what are those vowels? A comma O. 2 digits, correct? Vowels are A comma O, 2 digits. Okay, this is first basic concept. So assuming that no letter is repeated, repetition of the digits is not allowed. For all questions, for all three questions, what is given? Repetition of the digit is not allowed. Okay. 4 letters are used at a time. First one. First question. Four letters are used at a time. Okay. The total number of arrangements. The total number of arrangements is equal to 6p4. Correct? The total number of arrangement is equal to 6p4. 6 factorial divided by 6 minus 4 factorial. 6 factorial divided by 2 factorial. Correct? 6 factorial divided by 2 factorial. I solved here. 6 factorial divided by 2 factorial, that is equal to 6 into 5 into 4 into 3 into 2 factorial. 2 factorial, 2 factorial, 2 factorial get cancelled. 6, 5, 4, 3. Calculate. 6, 5, 4, 3. So total answer is 360. First question, 4 letters are used. So answer is 360. Correct? Answer is 360. First question is over. Is it clear? 4 letters are used at a time. First question is over. Second question, I written here only. Second question. First question is over. All letters are used at a time. Letters are used at a time. The total number of arrangements is equal to, all letters are used means 6p6, that is nothing but what? 6 factorial. Npn is nothing but what? N factorial. 6p6, that is what? 6 factorial. Okay. So I write this here 6 factorial. So that is equal to 6 into 5 into 4 into 3 into 2 into 1. So calculate. 720. All letters are used at a time. So answer is, second question answer is over. 700 what? 20. All letters are used at a time. 720. Okay, second question is over. Third question, yes, very important question. Third question. All letters are used, but first letter is a vowel. I write here. Third one. All letters are used, but first letter is a vowel. Correct? First letter is a vowel. All letters are used. All letters are used, but first letter is a vowel. So all letters are used. So we write 6 box. 3, 4, 1, 2, 3, 4, 5, 6. All letters are used, but first letter is a vowel. In this one, first letter is what? A vowel. All letters are used. First letter is a vowel. Vowels are how much? 2. This box can be filled in how many ways? 2p1 ways. Correct? 2p1 ways. Because in the word Monday, 2 vowels are there. We filled in one box. This can be done in 2p1 ways. Since repeating the digit is not allowed, so 1 is minus 1, 2, 3, 4, 5. So all these boxes can be filled in how many ways? 5p5 ways. Correct? All these boxes can be filled in how many ways? 5p5 ways. Okay. The total number of arrangements. The total number of arrangements is equal to 2p1 into 5p5. That is equal to 2p1 is 2 into 5 factorial. Correct? 2 into 5 factorial. So 2 into 5 factorial. So that is equal to, I written here, 2 into 5 into 4, 3, 2, 1. Calculate. $240. So answer is what? 240 ways. So see this problem carefully. Observe these 3 problems first, one by one. Next problem. Observe this problem first. This is very important problem. Next problem. Up to this we stop the exercise because the next problem, 10th and 11th, they are repetition of the digit is allowed. Until we solve, repetition of the digit is not allowed. Okay, different digits are given, but 10th and 11th problems, digits are repeated. We solve in the next class. For that, what we do, we solve some worked example problems. Okay, worked example problem number 12. So worked example problem number 12. So find the value of n such that, first question, np5 is equal to 42 into np3. N must be greater than 4. np5 is equal to 42 into np3. We stop up to that. We continue in the next class repeated objects. Okay, so we finish up all different non-repeated objects. Firstly, np5 is equal to 42 into np3. So we solve this type of problems in the exercise problem. Same problem. Given np5, n factorial divided by n minus 5 factorial, 42 into n factorial divided by n minus 3 factorial. Very simple question. N factorial get cancelled. 1 divided by n minus 5 factorial, 42 divided by n minus 3 factorial, n minus 3 factorial. So simplify it. 1 divided by n minus 5 factorial as it is, 42 divided by, this can be written as n minus 3 n minus 4 into n minus 5 factorial, correct? So n minus 5 factorial get cancelled. That implies n minus 3 into n minus 4 is equal to what? 42. n minus 3 into n minus 4 is equal to what? 42. Okay, so by inspection method or else quadratic equation. So n into n square minus 4n minus 3n minus into minus plus 12 minus 42 is equal to what? 0. n square minus 7n minus 42 minus 12 minus 30 is equal to 0, correct? So then n square minus 10n minus 10n minus 3n minus 30 is equal to 0. n take common, n minus 10 minus 3 take common, n minus 10 is equal to 0. n minus 10 is equal to 0 or n minus 3 is equal to 0. n is equal to 10 or n is equal to 3. One condition he has given. What he has given? n must be greater than 4. Since n greater than 4, that implies n is equal to what? n is equal to what? 10. n is equal to what? 10. Clear? Next question. One more question he has given. Second question. np4 divided by n minus 1 p4 is equal to 5 by 3 n greater than 4. 5 by 3 n greater than 4. Same type of problem. So np4 n factorial, this is given, n factorial divided by n minus 4 factorial, n factorial divided by n minus 4 factorial whole divided by n minus 1 factorial divided by n minus 1, correct? n minus 1 minus 4 factorial. is equal to 5 by 3. 5 by 3. Okay. So n factorial n into n minus 1 factorial divided by n minus 4 factorial whole divided by n minus 1 factorial divided by n minus 5 factorial is equal to 5 by 3. n minus 1 factorial, n minus 1 factorial what? Get cancel. Denominator of denominator goes to numerator, then n into n minus 5 factorial divided by n minus 4 factorial is equal to what? 5 by 3. n into n minus 5 factorial divided. This we can written as n minus 4 into n minus 5 factorial by 5 by 3. n minus 5 factorial, n minus 5 factorial get cancelled. So n divided by n minus 4, 5 divided by 3, cross multiplying 3n is equal to 5 into n minus 4. 3n is equal to 5n minus 20. Shifted here, 3n minus 5n is equal to minus 20. Minus 2n is equal to minus 20. Minus minus get cancelled. So right here n is equal to what? 10. The value of n is 10. Correct? So up to this we stop. We continue the remaining problems in the next class. Thank you.